Hello, everyone. My name is Daisy Ulloa. I am a PhD student working with Dr. Uduak George, and we are researching how tensional force alters the development of the mammary gland. So some background, the mammary gland primarily develops during puberty, and during this development, there are cells and collagen moving, creating mechanical force. The reason this is important is that mechanical forces are believed to play a key role in the formation of cancer. The goal with our project is to apply tensional force, which is a type of mechanical force, to the mammary glands, and study if and how tensional force alters or drives the development of the mammary gland. We also want to build an understanding of what normal and abnormal development in the glands may look like. To study this development, we're specifically looking at the epithelial branches of the glands, which are seen in purple on the right-hand side. So at 5 weeks, which is puberty for mice, the skin around the number 4 nipple is glued together, and this creates tensional force. As a result, the adjacent number 4 nipple is exposed to contralateral tensional force. So we have 2 experimental groups as well as our control group. At 7 weeks, microscopy images are taken of the mammary glands, and we created skeletal outlines of the epithelial branches in Photoshop. We put these outlines through an imaging software called ImageJ, where we straighten the glands. The reason we did this is that some of the glands, seen here, have a much stronger curvature than, say, other glands do. In order to take comparable measurements, it was important for us to straighten the glands so that there was consistency amongst all the data. We also put the straightened glands through another ImageJ plugin called OrientationJ, and that showed us the angle at which the branches are growing at throughout the gland. So what we found is that tensional glands grew significantly longer than the control glands, despite no difference in area, width, or any of the other measurements that we took. We hypothesized that the tensional glands are growing longer due to a difference in branching angle. So using our OrientationJ data, we binged the data 5-degree ranges, and we found that the tensional glands had a significantly higher proportion of branching occurring at -30 degrees compared to the control group, whereas the control group had a significantly higher proportion of branches occurring at 60 and -60 degrees compared to the tensional glands. So in summary, we did find that tensional force does alter the development of the mammary gland, and our next step was to confirm whether or not the branching angle is what is creating that difference we're seeing in length. So to study this, we created an in silico model using a random walk algorithm, which is a series of simple rules that can formulate a branching structure. So our simple rules are elongation, which we can see here, bifurcation, and intersection. What makes this algorithm unique is our other function called bias random value. So the way that it works is that the head node must decide where to branch to next, and it can do so within a window of angles. However, it'll prefer to branch to a specific angle that we give it. So simulated tensional glands prefer to grow at 30 and -30 degrees, and simulated control glands prefer to grow at 60 and -60 degrees. Once that angle is chosen, a line is drawn from the current node and the next node using this function here, phi tangent theta. And here we can see how several steps of this can create a long branch seen in green. So here are our results, and this is an example of a simulated tensional gland and a simulated control gland. We ran the simulation 9 times for each group at 25 generations, and we found that the simulated tensional glands did grow significantly longer than our simulated control glands, which is what we saw in our experimental groups. So this confirmed our hypothesis that branching angle may be what's attributing to that overall length in the mammary gland, and that tensional force does alter the development of the mammary gland. If you wish to hear more about this research or where we're currently taking our research, you can ask me questions at the ACSESS event later this month. Thank you.